Hello, my name is Darren Thomas, and I am the Director of Educational Research Techniques. In this video, we're going to be taking a look at one differentiation rule, and that is the constant rule. So let's go ahead and get started. So if you look at the graph up in the corner, I basically have the following graph of f of x equals 3. Not that deep here. And so as you can see, obviously that 3 is a constant. And obviously, again, if you're looking closely, you can tell that the slope, or any kind of change, if you will, is going to be 0. So the slope is going to be 0. And so if the slope is 0, that means the derivative is going to be 0. And so what we're going to do here is I'm going to show you the process of how we can verify this answer of this picture in this graph using what we know about limits and calculating derivatives. So let's go ahead and see if we can figure this out. So if we are doing, I'm gonna solve this on a theoretical level first using letters rather than numbers. If we're looking at the following, let's say we have f of x equals c. And of course that means that f of x plus h is going to also equal c. Again, this is something that we learned when we learned about finding the slope, or finding the derivative, if you will, using limits rather than these shortcuts that I'm going to show you now, which is what differentiation rules allow you to do. So if we keep this in mind here, this information right here, we are going to basically get the following happening here. So if I want to find the derivative of f of x equals c, is going to be as follows. So f of x is going to equal the limit of h approaching 0 of basically f of x plus h minus f of x. So you kind of have your initial position and your final position here, and then all this is going to be, of course, over h, which we've already talked about. Now, if we plug in our information where f of x plus h equals c and f of x equals c, we basically end up with equals the limit of h approaching 0 of c minus c over h. And we know that c minus c they're going to cancel each other. So we end up with we end up with the limit of h approaching 0. And basically, we're going to have 0 over h. And if I move over here, you're going to basically have the limit of h approaching 0, 0 equals 0. That's what's happening. So that's what's happening on a theoretical level. If we take what we just talked about and we apply this to our actual real slope right over here, f of x equals 3, you know we're going to get 0. But for those of you who struggle with this, I'm just going to roll it out for you real quick. So the derivative of f of x, f prime x, f prime x, f of x, f prime x equals 8 is going to be as follows. It's going to equal the limit of h approaching 0, but this time instead of c, we're going to have 8 minus 8 over h. So you can see what's going to happen here. So if we continue to work on this one, we're going to have the limit of h approaching 0 equals 0 out of h. And then finally, I shouldn't have a equal sign there. Excuse me, that's incorrect. And so finally, we're going to have the limit of h approaching 0 is going to be 0. Whoa, 0 equals 0. I know that's ugly. Let me fix that. 0 equals 0. And so again, if you look at our graph here, you can clearly see that there is no slope. There's no change at all. It's constant. And since it's constant, there can be no slope. Thus, there can be no derivative at any point on this particular line. So let me kind of wrap up what we talked about and conclude this video. So in this video, we learned about our first differentiation rule. And these are like the shortcuts for finding derivatives without having to go through all the process of using the limit function. And so we learned it for the constant rule. And so a constant is basically a constant value. It has no change at all. Thus, that means that whenever you are looking for the derivative of a constant, is going to be 0. And what we did here is we showed you how this works out in terms of actually solving it the long way using the limit function. And so you end up with, basically you have the constant subtracting from the constant over h, because there's no change. Since these values are the same, the c and the c are the same value, there's no change. Thus, you end up with an actual derivative of 0. And then we plugged in an actual number. Of course, over here I should have put 3. Excuse me, that's a mistake on my part. So this should be a 3, not an 8. So 3 minus 3, don't know what I was thinking, but it's because this is coming from over here in case you're confused. And so anyway, when we have the f of x equals 3, we found the derivative of f of x, excuse me, and the limit as h approaches 0. So it's 3 minus 3, and then of course over h, and so then you have 0 over h, and it becomes 0. When the numerator is 0, the value is going to be 0. So this is kind of how it works. And so as we go forward, we'll learn more and more little shortcut rules that we can use for dealing with derivatives that'll help us to understand how we can take these shortcuts to move things much faster. So my name is Derek Thomas. I am the Director of Educational Research Techniques. Thank you for watching.